Welcome to today's lesson on system of equations. Our do now is the robotic sponsors ordering shirts for a competition. The sponsor pays a one-time startup fee of $20. The shirt costs $7.50 per shirt. And the question is, which function can be used to find C, the cost of the shirts in dollars when N shirts are ordered? So C represents the total cost and N represents the number of shirts. So we know that our equation is going to be C is equal to something, right? And so the key word is one-time startup fee or just one-time fee. That tells you that that number is probably going to be the y-intercept. So we're going to look for something that has plus 20 or 20 plus. So we're going to cross out answer choice A, answer choice B, and answer choice C and D both have 20. One of them is plus 20, the other one is minus 20. Well, we know that it's $7.50 per shirt, so it's going to be 7.50 times N, and both of them have that. And the difference between C and D is that subtracting 20 would mean that we're actually taking away from the total cost, but we're actually adding to the total cost because there's that initial fee. So our correct answer for this do now is C. Our equation would be C is equal to 7.5N plus 20. Our TEK for today is 8.9a. Our lesson target is that scholars will identify and verify, which means to confirm the values of x and y, so a solution that satisfies two linear equations, which are also called system of equations, from the intersections of graphed equations. Then our DOL is given 4 problems. Scholars will identify and verify the values of x and y that satisfy two linear equations from the intersections of graphed equations with 100% accuracy. Some academic vocabulary words. So as I was reading the lesson target, I also clarified and used some of these words. So the first one is system of equations. So a system of equations is usually two linear equations, and sometimes the system has a solution and other times it doesn't have a solution, or it has multiple solutions. And a solution in this case will be the same thing, at least when it's a graph of two linear equations, will be the intersection. So in this example right here, the solution would be at this point right here, whatever the coordinates of that point is. And coordinates in ordered pair are interchangeable words, which means that you can use either one to describe the same thing. So when I'm talking about x comma y, that can either be called an ordered pair or a coordinate. And then slope-intercept form of a line is the equation that we've been using, which is y is equal to mx plus b, which is how we're going to be seeing these system of equations. There's other ways that linear equations can be written, such as standard form or point-slope form, but today we're only dealing with slope-intercept. So this problem reads, graph the following equations in slope-intercept form. We have y is equal to 3x plus minus 2, and then we have y is equal to negative 2x plus 3. So as you can see, the blue line represents y is equal to 3x minus 2. And just to confirm that we have graphed this correctly, we need to make sure that our y-intercept is at negative 2. If this is 0, this is negative 1, negative 2, so that's correct. And then our slope is 3, so that means that we're going to move 3 units up and 1 unit to the right. So starting from our y-intercept of negative 2, we're moving 1, 2, 3 up, 1 to the right, 1, 2, 3 up, 1 to the right. Okay, so y is equal to 3x minus 2 is graphed correctly. Then when we have y is equal to negative 2x plus 3, our y-intercept is positive 3. So just to confirm that we have the line graphed correctly, this is 3, and so that's our y-intercept. And since our slope is negative 2x, instead of going up 2 units, we're actually going to go down 2 units. So we're going to go down 2 units and to the right 1 unit. So starting at the y-intercept of positive 3, we're going down 2 units, 1, 2, and to the right 1 unit. And as you can see, that point right here is going to be our solution because it's our intersection of the two lines. It's where the two lines meet or cross over each other. We're still going down 2 units, 1 to the right, 2 units, 1 to the right, 2 units, 1 to the right, just to confirm that that red line is correctly graphed and that it is y is equal to negative 2x plus 3. So now we have identified what our solution is. So if each box represents 1, that means that this coordinate right here would be 1, 1. So in a complete sentence, I would say that the lines intersect at the point 1, 1, therefore it represents a solution to the system of equations. We can also use substitution, which is another method of solving system of equations, to verify, which again means to confirm that the ordered pair 1, 1 is a solution to the system of equations. So we have our two equations, y is equal to 3x minus 2, and then y is equal to negative 2x plus 3. And in this case, first we're going to label the point. So I know that the one is our x and the other one is our y. So I'm going to plug in those points into the equations. So we have y is equal to 3x minus 2. When we plug it in the points, we have 1 is equal to 3 times 1 minus 2. And so to confirm or to verify whether this is a solution to the equation, we have to see if both sides of the equal to sign are balanced. And for them to be balanced, they need to, equal each other. So we have 1 on the left side, and then on the right side, we have 3 times 1, which is 3, and then 3 minus 2, which is 1. So as you can see, 1, 1 is a solution to 3x minus 2 is equal to y. Then for y is equal to negative 2x plus 3, we're going to again plug in that same point. We have 1 is equal to negative 2 times 1 plus 3. So on the left side, we're only left with the 1, and then we have to solve on the right side. So negative 2 times 1 is negative 2, and negative 2 plus 3 is actually 1. And so as you can see, 1, 1 was also a solution to y is equal to negative 2x plus 3. Therefore, it represents a solution to the system of equations. So for this problem, we're given y is equal to 2x plus 5 and y is equal to 2x minus 2. And using a graphing calculator, we have to figure out what is the solution to the system of equations. And if there is no solution, why do the lines not intersect? And how could we change one of the equations so that there's only one solution? There's also 2 other questions, but we're going to go ahead and graph these 2 lines to see if there's a solution and what is the solution. So this is on Desmos graphing calculator. We have y is equal to 2x plus 5. So that first line is represented in red. And then the second line, we have y is equal to 2x minus 2. So as you can see, I'm going to change the color of that second line so that it's not red. Okay, so if we look, we can see that whether I zoom out or zoom in, that these 2 lines are parallel. And parallel means that they're going in the same direction and that they're never going to touch. So the reason being is that they both have the same slope or the same rate of change or unit rate, whatever you want to call it. Same constant of proportionality. I guess it wouldn't be called that in this case because this is not a proportional relationship, but representing our change in y over our change in x. They have the same value, which is 2. They just have different y-intercepts. So for one of the lines, for our red line, our y-intercept is 5, and for our blue line, our y-intercept is negative 2. So that answers this first question on whether there's a solution. So no, there's not a solution because they don't intersect, and the lines do not intersect because the slopes are the same. And we could change one of the equations so that there's only one solution by just changing the slope. So let's say I change the slope to 3 for that second line. So instead of y is equal to 2x minus 2, now we have y is equal to 3x minus 2. When we zoom out, we can see that there is now a solution, and the solution is at this 7, 19. So all I needed to do was just change the slope so that there would be a point of intersection where the 2 lines cross each other or meet. To answer this first bullet pointed question, given a coordinate plane that contains the graph of 2 linear equations, how can you identify the solution to the system of equations? So we can identify the solution to the system of equations by finding the point of intersection. So where the two lines meet is our one solution. If the two lines never meet because they're parallel lines, then there is no solution. And sometimes when the two lines are actually the same, maybe it looks different because there's different numbers, but it's the same value, and so the lines are the same lines, then there's multiple solutions or an infinite amount of solutions. And when you graph a system of linear equations, why does the intersection of the two lines represent the solution of the system? It's because it's the values, the x and y values, satisfy or make the equation true. So for this IG problem, it says graph the following equations and find and verify the solution to the system of equations. So we have y is equal to negative 2x minus 4, and then y is equal to 3x plus 1. So we have them graphed right here. And so the solution to the system of equations is going to be at this intersection point right here. And so if each box represents one unit, then if this is 0, this would be negative 1. So its x coordinate is negative 1. And then the y coordinate is negative 1, negative 2. So the solution is going to be at negative 1, comma, negative 2. And just to confirm that this is indeed a solution to both equations, I'm going to plug in, first I'm going to label negative 1 as x, negative 2 as y. Now I'm going to plug in the x and y values into the equation. So instead of y is equal to negative 2x minus 4, I have negative 2 is equal to negative 2 times negative 1 minus 4. And if I solve for that, negative 2 times negative 1 is positive 2. 2 minus 4, positive 2 minus 4 is negative 2. So that's true. And then for the second equation, I'm going to again plug in negative 1 and negative 2. So instead of y is equal to 3x plus 1, I have negative 2 is equal to 3 times negative 1 plus 1. So 3 times negative 1 is negative 3. Negative 3 plus 1 is negative 2. So we have just confirmed or verified that negative 1 comma negative 2 is a solution to the system of equations. This next ID problem reads, Celeste and Ryan are selling world's finest chocolate for JROTC. The graph shows a linear relationship between the number of chocolate bars each of them has left to sell and the number of days that they have been selling the chocolate bars. On which day does it appear that Celeste and Ryan will have the same number of chocolate bars left to sell? So on this graph, our y-axis represents the number of chocolates left to sell, and our x-axis represents the number of days. Because remember that usually our independent variable or our x-axis will be time, if that is a factor in the situation. So I'm just going to quickly label that x and y. And over here, I can see that the two lines intersect at this point right here. And that is at day 6. So that means that the solution to this problem is B, day 6. Now you have your 4-question DOL that's in Google form. Thank you so much for following along in today's lesson, and see you in the next math video.